Today's notes will be about temperature and thermodynamics, so please label your notes temperature and thermodynamics, as well as write today's date in your notebook. So we've talked a lot about solids, liquids, and gases this year. Gases, hopefully we remember, move really fast, and solids move the slowest, but those particles are still moving. And then we see that gas particles are often very far away from each other, and we can make all sorts of conclusions by looking at solids, liquids, and gases. So what is energy and motion? Maybe you remember this from physics or earlier on in the year. We've talked about different types of energy, and energy in motion is called kinetic energy. So we'll talk some about kinetic energy during this unit. So please write down that energy in motion is kinetic energy. So which of these has the highest kinetic energy? So we're talking about energy in motion. Which has the most kinetic energy? Take a second, think about it. Gases. Gases will have the highest kinetic energy because those particles are moving the fastest. They have the most motion. So draw this picture. So you remember your solids, liquids, and gases, but also point to the gas as the one with the highest kinetic energy. We'll think about that idea a lot this unit. What is temperature? Well, temperature is a measure of the average kinetic energy of a sample. So think back to what you did in class, and if we look at the average kinetic energy of a sample, if all of the objects that you took the temperature of had the same temperature, they all had the same average kinetic energy present in them. Temperature is proportional to kinetic energy. That sign means proportional to. Make sure you have the definition of temperature written down, as well as that it is proportional to kinetic energy. So therefore, as temperature goes up, what happens to kinetic energy? Well, it will also increase. So the higher temperature something's at, the more kinetic energy it has. So if we think of the word thermometer, what words are hidden in thermometer? Well, thermo, which we just talked about, we'll be talking about thermodynamics and heat transfer, and then meter, the measure of. So the measure of our energy in motion. So when we take a measure, when you take the temperature of a sample, like I just said, we're measuring the kinetic energy of the sample. So make sure you have all these notes written down so you're prepared for quizzes and tests. So also in class, you should have done some practice with some equations. And these are the three major equations that we'll be talking about in this unit when we're talking about temperature. So degrees C, of course, is Celsius, F is Fahrenheit, K is Kelvin. Make sure that these equations are already in your notes. They should be. If you would like to see any practice with these, make sure to refer to the Paradoc from class or ask your teacher for more examples. But you will be expected to use these equations. Temperature, so again, we just talked about the difference between those temperatures. We were really reading those kinetic energies. But we still felt a difference. If you touched the metal, it may have felt colder than if you touched, say, a pencil. And what you feel there is the heat transfer. So we're now going to shift gears and talk about energy transfer. The energy that is transferred is called heat. So write that down in your notes. Energy transferred is called heat. And heat always transfers from hot surfaces to surfaces lacking heat. So for example, if your computer is hot because it is running, the heat will transfer first from your hot laptop to your hands. That might be lacking heat, not quite as hot, and that is how your hand warms up and feels that. When the two objects reach the temperature, they are said to be at thermal equilibrium. So when they reach the same temperature, maybe they're both at 80 degrees Fahrenheit, would be pretty hot. That would mean they both have reached thermal equilibrium. We have a couple laws of thermodynamics. Likely you've heard these before in previous science classes, but the first law of thermodynamics, write down, is when heat is, first law of thermodynamics states that heat is conserved. Energy cannot be created or destroyed. So it's always transferred from one thing to another. So very similar to the law of conservation of energy, but this law is saying that heat is what is conserved. Then the second law of thermodynamics, please write down, is that energy tends to disperse. The universe is in an increasing state of disorder. So therefore, if we're in this constant state of disorder and things are constantly dispersing, a house will eventually fall down because of the energy being dispersed. Or sandcastles, you might see they slowly crumble away. And then it's also important to note that energy is absorbed by a substance when it warms up, melts, or boils. It is taking energy in because the heat, of course, is coming to do those. Then energy is released when it cools down, condenses, or freezes. Make sure to write those 2 bullet points down. But that makes sense because, again, on the last slide, we said that heat transfers from hot surfaces to surfaces lacking heat. So if something is warming up, it is taking that heat in, or if something is, if heat is being released, it will cool down. So make sure you have those notes written. Feel free to rewind any parts of the video to take notes down if you have any parts that are missing. Then we have 5 practice questions. The first 3 will be conversions for temperatures. Make sure to show your work and your units for credit, and then answer questions 4 and 5 as well. Pause the video, answer those questions. Once you're done, please submit a clear picture of your notes and your practice to Google Classroom. And that is it for tonight's homework.